Alright, stream time. See if this is working. Alright, seems like it's working. Let me just pull up my phone real quick. See, alright, that's working. Let me see my videos and where's my live stream? There you go. Alright. Hello everybody. Today we're gonna go over Scratch. Everything from the basics to what you need to know to be really good at it. So we'll start with it's gonna be about 3 parts basically. We'll start with the basic Scratch functions like the user interface, all of these blocks, and how to use everything. After that, we'll start making some basic projects, so we'll get that knowledge from all these blocks and stuff, and we'll use them to create a project. Third part, we're actually gonna make a project that can be edited and modified to be the final project. Alright, first, this is the online version of Scratch 3.0. This is what we're going to be using. And here, let's title our project real quick. So let's title it tutorial. There you go. Alright, this is called a sprite. Each sprite has a name along with some attributes to it. So here we can change our name of the sprites. So let's just do it, just sprite 1 for now. This is the visibility of the sprite. Size, direction, don't worry about this for now. If we click on the sprite, we selected that sprite. We could have multiple sprites, so it's important to click on the sprite you want to use. This is where the code goes for your sprite. We'll use the code in a minute. Costumes for the sprite. This is how the sprite will look like. So I can change this here. We are in vector mode right now. There's 2 types of images, vector and bitmap. Bitmap images are all pixelated like this, so if we zoom in, you can see that these are all made out of pixels. Oh shoot, let me undo this real quick. Control Z means undo, or you can click undo over here. Vector mode is a type of image where no matter how much you zoom in, you won't see any pixels, because all these curves are mathematically defined. So vector mode can be very important if you want a visually appealing image, I guess. But they're also sometimes hard to use. But we'll stick with vector for now. This is our select tool. We can change the vertices here. Like here is select, and then we can change the vertices. There's eraser, paint, fill, text, circle, line, and square. But we won't worry about that. And there's also 2 costumes for this sprite. That means that this sprite can look either like this or like this, and we can change that later. Both of these will run on the same code though. Alright, now that we have our sprite, we want, say, this sprite to move. Motion is moving, so any of these will move the sprite. Okay, so if the block looks like a rectangle of some shape, that means it will perform an action. If it's like a circle or an oval, that means it is a numerical variable type. So all these are numericals. So that means whatever this is, it'll have a numerical value corresponding to it, like size. There's a numerical value corresponding to it. Volume, numerical value. If there's a hexagon space, that means there's a Boolean value corresponding to it. A Boolean value is a true or false. So is touching mouse pointer, that is a Boolean value. It's a hexagon. It will be either true or false. Touching color, true or false. So that's a Boolean value. We have numerical value again, except this one. This numerical value is not necessarily numerical value, but that's a special exception. We'll get to that later. And these are operators. We can basically add numerical values or compare, like logic gates. And we'll get to variables later. Alright. So, now that we know all the types of blocks, let's actually get to coding. If we want our sprite to move, we want an event. An event, here, I'll write this down actually, just in case. Event is anything that causes or performs an action, or calls an action. Let's go. Oval shape equals numerical value, and then hexagon shape equals boolean, which is true or false value. And then events are anything that causes an action to happen. Because they're either called or they can, I guess, be broadcasted. Yes, I'm going to save this on YouTube after the stream is done. Alright, so the most common event is the when flag clicked. When flag clicked is basically when this project is started, anything with this event will be called, and anything that's called will have their code run. So it will move 10 steps in whatever direction it's facing. And 10 steps correspond to pixels in this case. And this board is 240 by 180 pixels. Origin right here is 0, 0, and we can go y 180, x 240, y negative 180, and x negative 240. So that is our board size. We can also have events like this. These are called listener events. They will listen to something. So when space key is pressed, so when I press the space key, that event will call. So I can also do this, and the cat will also move. Also, we can click and drag the cat to move it to any place we want to. Whoa, alright, anyways. So now that we basically know what events are, let's learn about the other types of code. So, as we already said, Manus is in there, but whatever. These are all motion types. They'll change the motion. Let's go over all these real quick. So, turn 15 degrees. This will change. That was a weird voice crack. Change the direction of the sprite in the XY coordinate plane. There's also a type of direction called left-right, which means the sprite can either face left or right, but that's usually not useful in this case. Yes, you are here. Alright, so when I press space, this will move forward and also turn right. But it will turn right before it moves forward, so it will turn and then move, turn and then move. Alright, this is also counterclockwise turn. Go to random position. This is a go to command. That means this sprite will go to a different sprite or object or anything of that sort. This is a numerical value. As you can see, there's an oval. So a numerical value can hold obviously a number, or it can hold an object or a variable. Yes, I guess I'll respond. Alright, so this is a numerical value. We can save this position and move the cat towards an object or a position. So if I make a new sprite, which I can do by clicking this means upload an image for the sprite, so how it looks like, not any of the code, unless your code is predefined. You don't have to worry about this, it's just random. This is if you want to make your own sprite, which we can do here. It will bring you up to this screen and you can make your own sprite. And this is if you want to choose a sprite from the large library that it has. So let's start with making a sprite. I'm just going to make a circle. Your circle will look like this. Control Z to remove. This is a fill. This is what it will be shaded in with. This is the outline, like outline of the shape, and this is a stroke size. Stroke is basically line thickness. So this is how thick the outline will be. We can press hold shift to make this a perfect circle. That goes with a line as well. Lines are like this, but we can press shift to make it perfectly 90 degrees or 45 degrees. And same with rectangle. We can make it a complete square if we press shift. You can also press shift while we're here, or control, or again, never mind, that's PowerPoint. Alright, anyways, so let's create a small little circle here, and say we want this cat to go to the circle. Then we can use this code, sprite 2, that's the circle. Here, let's name it circle. Then it will go to the circle when space is pressed and then move 10 steps. Obviously, you can't see it move 10 steps because it keeps going back to the circle when you press it. Alright. Go to and the two numerical values. This means go to an exact position on the screen. So this can range anywhere from -240 to 240 and 180 to -180. Or is it 160? Or we can go anywhere you want. You can make it go to 500,000 if you want. It's just you can't see it. So we can do that. So say I wanted to go to 0, 0, which is the origin. Then it will go to, oh shoot, space, 0, 0. And x is left and right, so if I want to make this go 100, which is around here, it will go there. And if I want it to go up, it will go there. Alright, glide. Glide is kind of weird. You usually don't see code like this, but glide basically means go to and then a numerical value, or you can use the integer exact coordinate values here. It doesn't have to be integer actually, it can be any type of number. Basically, glide is go from whatever position you're in to this position or this position in a certain amount of time. So if I say glide 5 is a little long, 0.5 seconds to the circle, then it'll take 5 seconds to go to the circle. So let's do that again. The speed will also, the speed of the cat will also depend on where you are. So obviously, if you're closer, it'll go a lot slower. Get to the climate change part. Well, if you want to understand Scratch, you gotta understand like the types of code that runs thing. So I'll skim over it really quickly then. Point in directions basically point in whatever direction. Point in a direction towards an object is basically pointing towards whatever object it is. Change x by, these are all changing and setting the x value, which is basically the go-to except a little more customizable. This is the rotation style that I was talking about. Left-right means you can only face left or right. All around is you can face in any direction, like 10 degrees, 50 degrees, 120 degrees. And don't rotate means it is not rotatable. These are different numerical values. As we said before here, these are numerical values. It means this will hold a numerical shape depending on where this is located. Right now it's located -97 and -6. So if I decide to use this, say x position for 2 seconds, then obviously it'll say whatever value this is, 60, and then it'll glide, because everything goes in order. Alright, we won't really be using the looks, but except for these, but these basically say hello, or any text value or string type value for a number of time. These are if you want to change how the costume looks like. So if I want to change between the costumes, I can do that. And backdrop is the background of your scene. So if I do that, and then do that, then that's how the background of the scene will look like. But we don't need that now. Also, if you guys don't know what this is, color is basically what color it has on the color wheel. Saturation is saturation, and brightness is brightness. I mean, there's not much to explain about that. Change size is changing the size. Simple, not compounding. Okay, simple, not compounding. So if I want to change size by 10, that means it'll change the size by 10%. So 110, 120, 130. While setting size sets the size. These are different effects that you can put on the object. So if I change the color effect by 25, that means it'll change the color. Actually, let's get rid of this glide and hello. So change the color of it by increment of 25. 255 is usually the increment for color. And any other effect, you can go to an infinite amount. And we can also set this to 0 to put it back to normal. And we can also clear. Some of these will only go up to a certain amount, such as brightness and ghost. They only go up to 10 or 100. Brightness and ghosts, kind of self-explanatory though. Brightness is how bright it is, and ghost is how transparent it is. Show and hide is to show and hide the sprite. Yeah, let's put this back to normal color. And layers. Every scene has multiple layers to it. So, say this circle is behind this cat. So that means this cat is in a front layer, which will be very important later on. And you can change layers as well. These are numerical values, costume size, etc. Don't worry about sound. Events. We already went over events. Controls. Controls are going to be very important. I'm going to talk about that later in sensing. Alright. So we have the basic stuff. Now we're into the advanced stuff, or intermediary stuff. We're going to start coding some very basic things now. So I'll get rid of this sprite. We have our circle. Just a circle costume. First, let's make the circle move when we use our WASD or arrow keys. So, let's go here to events. When the flag clicks, so when you start the program, forever, we want it to listen to any keys that you press. So if is a conditional statement. So this hexagon here, that's a boolean or true or false value. So anything on the hexagon, if it's true, it will run this code. If it's not, it won't. So if this is true, then it will run this code. So if, say, I press the left arrow key, we can do that here. Key, left arrow is pressed. Then it will run whatever code is in there. In this case, we want it to be change x by, say, -5. So if we run this, and if you press left, then it will obviously do that. Now we can also do this multiple times to do it for a different arrow. So if we press right, that means this statement will become true if we'll recognize that and run the code inside it. So let's change y by 5, -5, down and up. Now there's a reason why I did it like this, because usually you would think that, where is it? Here. When you press a key, then a thing is run. So when I press up, I can also do that, and that would work. Except you can already see the problem. When I press up and hold it, there's a delay between when it actually moves. So it moves once, it delays, and then it runs again. It's not something you can fix unless you put well, actually we're not going to talk about that. But it's not something you can easily fix. And it also causes a lot more lag because we're running multiple events at once. It's not too much now, but it adds up over time. So we will usually stick with it like this. You can also prevent, I guess, lag if we separate these up into different functions, but we'll learn about custom blocks toward the very end of the video, because custom blocks are a little weird. Oh shoot, I got rid of this. Alright, so now that we have this, let's go to sensing. We want this to stop when it touches anything black. So let's just add a black square right here in the middle. There you go. You can also change the layers here and stuff like that. Alright, circle, and let's go back to the code. So our circle is moving freely, but we want it to stop moving when it touches something black. So, how do we know if it touches something black? Well, we have this touching color black code here. This is a boolean statement because obviously it is a hexagon. So, if it touches black, then this will turn true. So if I get my if touching color black, then this will be true. I can click on this and it will say it, so it's false right now, but right now it'll be true. So I can put this here. Also, we don't want too many if statements in a single forever loop because that's a lot of stuff to run continuously. I usually stick around 10 at most, but it also depends on how much code you have. So if touching black, first we want to see if this works. This is a very important step. You always want to debug. So basically you want to prevent any bugs from happening. So say true for 0.1 seconds. So now we know that it is. But you also notice that it will actually run the code every 0.1 seconds. This is because this code is being run. And when this is being run, none of this can run because currently the code is preoccupied on this. So if we're going to use a debugger, we'll also have to use it in a different forever loop. So it does not clock this. And let's run this. And now you can see that it will actually say true without actually delaying. Alright, so if you want this collision to work, there are multiple ways to do this. One of the most basic ways is to do it like this. Alright, so if touching color black while going left. So if I'm pressing the left arrow and it touches black, that obviously means we have to move it back in the direction that it came from. So let's go here. Then I can't move there because I'm pressing left. I'm trying to go -5 in the Z or X position, but I'm touching color black, and it will obviously push me back out. Now I can do that to any other face, and that will also work as well. But I'm assuming that you guys already know that. So we're gonna skip all the other basic stuff. Alright. Let's see here. Operators. These are called logic gates. Logic gates are very important in Scratch because they allow you to compare multiple things at once. So if this is true and this is true, then this will run. If this or this is true, this will run. And if this is not true, it will run. You can also have nested logic gates. Nested is basically they're in each other. So this is called a NOR gate. So if this or this is true, then this will be true. But we don't want that to be true, so that's a NOT. Also nest this even more. So if this is true and etc. That's also very important. Alright, I'm going to assume you guys all know the basics now, because these other ones, well, we basically went over all of these, except for some of this, but we won't use that. And I'm assuming that you have either watched or seen any Scratch tutorials or played with it by yourself. So now we're going to actually move on to advanced stuff. We'll start basic with the advanced, and then we'll move on to actually really advanced stuff. Alright, so here we're going to make a ground. We're going to make a basic platformer. And then at the end of the video, I'll make the actual climate change. There you go. We have a rectangle. We're going to use that as the ground. So how do you make a basic platformer? Well, platformer essentially is any game that involves a platform set and a character and gravity and stuff like that. So first, we want this ball to fall due to gravity. How are you going to do that? Hello, save toxic. Okay, so go to variables. Let's delete this variable and make a variable. This variable can be the gravity variable. How strong do you want the gravity to be? Well, actually we need 3 variables: x velocity, y velocity, and z velocity. Okay, if you know how to do gravity, there's probably different things that you didn't know, and there's different ways to do gravity as well. So we're going to set gravity to 0.7. Now it's important to have a gravity variable if you want to use collision boxes. So like if you jump up and you hit your head, then you have to fall back down, not go through or be stuck. If you hit the side of a platform, then you don't stay in the platform, you gotta actually bounce off. And collisions are important basically. So we have our, oh shoot, I named that the wrong thing. Gravity, there you go. And we're gonna make our x velocity and our y velocity. If you want to, you can skip this and come back in like 10 minutes then. Alright, so let's start with this and a forever loop. And we want this ball to change in its position relative to its velocity. So we're also gonna not add a terminal velocity unless we want to. So here, so we want to change the y position because y position is vertical by its y velocity. Alright, we also want the y velocity to decrease depending on its previous y velocity. So we can set the y velocity. Okay, let's set these to 0 at first. That means there's no y velocity. So I'm going to set the y velocity. We can also do change y velocity by negative 0.5. This would work as well. This would be a quadratic graph if you look at it. That is a very good simulation of gravity, and it's accurate to some degree as well. But usually you want to customize your gravity and not have it just like this. I'm not gonna tell you how to customize your gravity necessarily, like to a huge extent, but you can set gravity to like y velocity times an operator and then change y velocity by gravity, or 0 minus gravity. So there's two ways to do this. We can set the y velocity. I never like set this before, so it's kind of weird phrasing it. But we can set the y velocity depending on the gravity, or set the gravity depending on the y velocity. So say we set the gravity to 0.5. This is the same thing as before. And we can also change this gravity, so change by y velocity over 100, for instance. This is obviously not accurate. This is too small. And we also have to have something to start it, so 0.1. Alright, oh shoot. Okay, that's way too strong. Oh, that's not division. There we go. Because usually in programs we want a variable that corresponds to a variable to be relative to that variable. Okay, this is too slow. I should probably change this to 2. Okay, well that's too slow too, but oh, I limited this. Okay, I guess we'll start out like this then, because I did not do this for a while. I'll pull up a previous project with it though. So let's start out with this. Now we want it to have collision with the ground. So we can go back to our previous Boolean statement. So if it's touching the ground, usually we don't want to use the color, because if we have something else with that color, then it'll also react to that. But there's a workaround to that, and we can also make it not respond to color. That also works as well. This is a color picker, eyedropper is what it's called. You can use that. So if touching color, this will be run. We want it to obviously reverse the y velocity, so it'll just bounce back up. So we can just set the y velocity to negative y velocity. There's two ways to write a negative. We can do 0 minus y velocity, because that will make it negative, or we can use that join block. Oh, that's not y velocity. Y velocity, there we go. Let's set this up here. So this is what you would usually use, except there are a lot of bugs to this. First, you can see that the ball is going into the ground a little bit. We don't want to do that. And second of all, this gravity is really high. So you can change the bounce height by multiplying this by a gravity variable, or usually you just stick with a gravity variable. No, that's not it. What am I doing? I'm using a gravity variable instead of inputting these. So if I have a lot of y velocity equals blah blah blahs, then instead of just going through all of these numerical things, I can just change this one value and I'll change all of it. So here we set it so the bounce height is 60% of the original. But now we can see that the ball is actually sinking into the ground. How do we fix that? Well, this is where functions come in. Make a block. Functions. I don't know if you guys know what functions are. Functions look something like this: public, void, on, click, whatever inputs here. That's a function. In Scratch, we represent that as a block. So this is the name of the function. We can have inputs, we can have Boolean inputs, and we have our outputs. That's what a Scratch function looks like. Now what a function does is it runs code depending on its inputs. So if I make a block, this is the name of the function. So I wanted to check if it's in the ground, so I can do check ground. And these are inputs. So if I have a numerical input, and okay, so say I have a function called check ground, and our numerical input is a numerical input, so number. So this is our function. Same thing. Oh, my bad. Oh. So if I run this function, so if I put check ground and write in when flag pressed, and I put check ground, this function will be run. Actually, we have to have a number input, and it'll call something. So if I say y velocity plus equals number, or in your terms, y velocity equals y velocity plus number. Now, this does not mean it is equal to. This means set whatever value this is to here. So here, set y velocity to this. This does not mean y velocity is this. This means set whatever value is here to this. So it's like a storage container, and we're setting whatever this is to it. That is important functions. So I'm running the check ground with a 0. That means I run this and number will equal 0. And I change the y velocity by nothing. But if I change this to 5, that means I'm running check ground with number, and y velocity will increase by 5. If I do 15, y velocity will increase by 15. Alright. There's also something called run screen without refresh. This means the entire function will run at once without a screen refresh. Now if there's an infinity loop or something inside that function, that means your computer is going to crash, because, or Scratch or Adobe Flash Player is going to crash because it won't stop running. But we're going to need that in this case. No, shoot, I did not name that round. So let's make a check ground function and run without screen refresh. We'll also add a Boolean input, and this is seeing if it is actually in the ground. So is it touching ground? Usually you don't want to use question marks. And we can also add a label if we absolutely need to. So this means, is it touching the ground? If you have a lot of inputs, then this might be useful. Alright, so this is what our function looks like. So if it's touching the ground, we wanted to check if it's actually in the ground. So we're going to run this function, and this is a Boolean variable. Alright, we don't want to run this yet. So check ground. If this is true, then touch ground over here will be true. If it's false, then touch ground over here will be false. So let's see here. So if touch ground is true, what did I do? I added a comment. My bad. I can extract this. So if touch ground is true, Boolean variables, you don't have to say if touch ground is true, it's just if touch ground. So if it's touching the color black, then we want it to go up. So we want to repeat until it's no longer true. So repeat until not touch ground. Oh, and we want it to go up. So we're going to change our y by 1. Alright, let's not make it spawn in the ground. So let's see here. Go to 0, 0. Alright, it looks like something failed over here. Alright, okay. I did not expect this, but it will be a good chance to debug. Now, debugging is very important because you need to fix problems in your system. There are many ways to do that, but most common way is to take out some parts of it and change it with something else. So we know that this will be true if it runs. So it is running. Now we can do this and to see if this runs or not. It is running. And we can do this. And we can see that this is where the project fails. That means there's something wrong there. Let's break this down. When this is true, then it will run this until it is no longer true. And oh, okay, I see the problem. We're gonna change this to not run without screen refresh because at the time when the function is called, it is always true, and the function will run it when it's not, or until it's not true, but it's not working in this case. So we'll just try it out without the screen refresh. So in ground, there we go. Check ground in ground, and let's just copy this code. Actually, we can't do that because these aren't the same. In ground, and let's get this. Oh, not in ground. And touch color black. Alright, so now that we can see that it works, we want this to be instant. So we know this works. It's just there's something wrong with the instant. But if you look closely, we notice that this is always going up. Why is that happening? Well, functions, when I call a function, this will always run as long as this function is called. When this is touching black, oh, this will always run. So this doesn't know when to stop until it actually goes out. Usually this wouldn't happen in Scratch. A lot of programs, they usually stop it, but some programs, I didn't know Scratch did this until 3.0 update apparently. We'll just keep doing that. So we have to stop that script. There's two ways to stop scripts. Here we can stop this script, which will completely stop the script. Okay, that's not working. Or we can actually call a function that stops it. So first we had to debug this again. Say hello for, we want this to be short time so it updates very quickly. Actually, let's do this too. It's not saying hello. What? There we go. So now we know. Actually, let's change to that bigger margin. That there's something wrong with this. Okay, so repeat until not touching black. There's something wrong with this right now. What is wrong with this? Well, there's no way to tell that unless we debug this as well. Say it like this. So say either true or false. If this is not true, or repeat until this is not true. This is true. Or in ground is true. So repeating this until it's not true. So I have no idea what's wrong in this case. Repeat until not true. Alright, well, I guess that's a Scratch bug. I'll go file that bug later. The other way to do this is actually use the not touching black. I guess we have to use this in this case. Let's see if it works. And yeah, it works. So yeah, I guess the scratch bug. Alright, anyways. Oh shoot, let's get rid of this and let's go back to here. Alright, now our ball should not be stuck in the ground no matter what. And our Y velocity is going crazy a little bit, but that's because when it touches the ground, it flips itself, and it just automatically does that. But that will cause a lot of lag to the program, so we're going to prevent that. How will we prevent that? Give you 10 seconds to think about it. Alright, 10 seconds up. So, we can see that when it fluctuates, what is that value? That value is very close to 0. Actually, it never goes above 1 or below -1. So if this Y velocity is closer to 0 than 2, or -2, so if it's under 1 or greater than -1, then we want this to be 0. How do you do that? Well, we can use the absolute value function. So if the absolute value of Y velocity, where's Y velocity, is less than 0.1 or 1, so we already mentioned this. Absolute value basically changes the negative to positive. I mean, there's math behind it, but that is essentially what it does. So if Y velocity is -1, then we're just going to change this to 0. Y velocity 0. And that will, what did it do? That will set the Y velocity to 0. Now, another important thing is the order of this. Order wouldn't be too important right now, actually, so we're gonna not do that. We also don't want this to run if the Y velocity is 0, because that won't do anything. We're multiplying 0 by 0.6, that's not doing anything. And we're gonna prevent lag, so we're gonna change this if to an if-else statement. If else means if this is true, it'll run this, but if it's not, it'll run that. So we want to see if it's less than 1, and if it's true, it's just gonna set it to 0. If it's not less than 1, we'll actually have to calculate it. But if it's less than 1, there's no point of calculating it, because that's just a lot more work. Okay, well, I guess. Oh, I see our problem. That's not actually running. That's because of this. Alright, well, it's okay. This basically neglects this, and this is setting that back, so that's why that's happening. Alright, anyways, yeah, I need to eat chocolate or something. Now we're going to set our x velocity. X is our horizontal velocity. So there's, again, many ways to do that. If I go look at a platformer, actually I won't do that. If I go left, so say I go left, we already mentioned how to do that. We're going to run that in a different forever loop, because that's gonna be a lot of if statements and a lot of calculations to handle. So if I go left, so if sensing key left pressed or right pressed, what's right? Oh, there you go. I can do it like this. Change x by 10 and x by -10. This is linear. That means I switched these around, didn't I? This is linear. That means the speed at which it moves is constant. It's not going to do anything except move left and right like this by a constant speed. If I press for a short amount of time, it doesn't do for a short amount of time. It just moves by 10. And that's where velocity comes in. So you can do the same thing we did here. X velocity. And actually, let's do x velocity and negative x velocity. There's also two ways to do this. You can actually change the x velocity if we move the left and right arrow, or if we press it. We can change our x position by that, or we can change our x velocity and then move our X position like that. I guess I'll go with the first way because that is a little bit more efficient. So change, oh shoot, X by X velocity, and then I'm not looking off anything either, so I might make mistakes. Not that I should though. Set X velocity to -1, or actually let's do -5 and 5, and we obviously want it to be 0 when you start. So we have a velocity now, but we also want it to slow down because there's friction. We can also change, or you can make friction a variable, which means depending on what we're like touching, you can change that friction value so it has different frictions. But we're not going to be worried about that too much right now. So we can do change X velocity, or set X velocity to half of its previous, or actually let's do a ninth of its previous amount. So X velocity times 0.9. So basically, no matter what direction it's going, it'll slow down eventually like that. You can also have a gradual speed up. So right now if I press right, then it'll go right or left instantly at top speed. So this is the top speed right now. And then it'll slow down if I let go. What if I want it to be gradual speed up? Then if left arrow is pressed, instead of setting, we'll actually change this to change X velocity by let's see, change X velocity by -1. Now this means the top speed is 9 in any direction. So it can't go faster than 9 because, or I mean it can go faster than 9, but it can't go faster than 10 because if you're at 9, then also this is 0.81, 0.91, and so on. It'll become 10. That'll become 0.9, and it'll become 10, 0.9, 10, 0.9. So cancel out at 10. So 10 is going to be our top speed. We can also change our top speed to, say, a lower number without changing this X velocity. We're just going to if else statement here. If else, if else. So if, and then this is where we're going to use our top speed. So say top speed is 5 in any direction. So if X velocity is less than 5, there you go. Wait, this is left arrow. So if X velocity is greater than -5. Oh, they changed the you can't change this thing anymore. But I don't think you guys would know that unless you used to like Scratch for a really long time. But alright, this means if it's going less than 5 per second or per frame update, then don't change it. Or else, if it's too fast, then it won't move it. So you can see that there's a gradual increase by an increase of -1. Now our speed isn't constant, but that's just because we're setting this, and we're also setting this. Alright, with practice it's possible to do all of this in less than 45 minutes under pressure. Okay, well, all of this I can probably do in 5 minutes or 3 minutes. So I guess so. Is there like a 45-minute time limit? Because then we might need to use lists instead of variables. I think those are easier. Alright, actually we don't need this if else, we can just use an if statement. So we'll go if and move this to here and move this to here and get rid of that. And if move this to here, move this to here, and get rid of that. So now we have this. Alright, now we want to have the jump. Most events are 50 minutes, so there's time. Yeah, you can do everything I just did in 3 minutes of practice. It's mostly just practicing logic. I can show you like actual code if you want me to. I don't think that's necessary though. Alright, so when we want this to jump, we want to increase its y velocity because that's how it is moving by. If we set the jump to 5, that does not mean it's gonna move 5 pixels up. That means it's gonna move 5 pixels up, and then update this 4.5 pixels, then forward and 3 and 2, or 3 and 2.5 all the way to 0, and then negative 0.5, negative 1, and it'll go like a parabola. That's exactly what we want. So if you want to jump, so let's see here, when sprite clicked, forever, if I'll just copy paste this. Where is it? There we go. If up arrow is pressed, then we want this to jump. So we'll set our y velocity to 5. So let's wait for this, and when we jump, okay, I've kind of press hold of that, but if I quick tap this, there will be a jump. Now you can already see a problem that if I hold this indefinitely, then it'll go up indefinitely. That's obviously a big problem. And I can also press this and then like press this again in the air. There's obviously ways to fix that as well. So for the indefinitely part, actually let's change our jump to be a little higher because that's really low. Let's change our jump and boom. Oh, that's a good jump. So we want this to only jump when we press it in the first instance, and then we have to wait until we stop pressing that for it to jump again. So if key up arrow is pressed, change this, and then we want to wait. There's a wait function right here. Wait until not, and then the key up arrow pressed. Remember, if there's anything that takes time, like remember we did that look and then say hi for 2 seconds, this is a wait, so that's basically taking time as well. Then it'll stop this entire script because of this. That means it won't check if the up arrow is pressed, which is what we want. So I'm pressing up arrow completely right now. I'm not letting go. But it's not jumping. That is what we wanted. But if I let go, you can see that there's a problem again. You can jump in midair. Now, I mean, I guess that's useful if you want like infinite jumps, but we don't want that. Say we want a double jump ability. How do we do that? Now we're going to need a jump variable. This is to keep track of how many times you jumped. So jump, there you go. I'll also share this project at the end. And if you guys want me to make a specific project like Tetris on Scratch or like Battle Cats on Scratch, well, I can't do those because that involves way too much customization, drawing, and stuff. But if you want me to make a project, then I'll do that. Alright. I'll do that as a separate video. Not live stream, but video. Here's a jump. So depending on how many times we jumped, we want this to increase. So when we press this, we increase our jump by 1. Now we want this thing to only jump. No, it's not possible to do this in 15 minutes. It's too long. Okay, well, I'm explaining everything. I mean, if you want me to build this entire thing again in 10 minutes, I'll be able to do it. It's just mostly practice, I guess. I think Bill could probably do it too. So, our jump is at 10, 12. So it increases every time we jump. Now this is really useful. We can just say, if jump is greater than, say, 2, then we don't want this to run. We also need to reset our jump. And that's also very easy too. If we touch something black, like the ground, then that resets the jump. So if touching color jump, then we set this jump variable to 0 again. Boom. So if we're in air, then this will increase, and it'll go back to 0. That resets the jump counter. Alright, and then now we want it to double jump. So, don't. Oh, okay, I won't do that. Alright, so if key up arrow is pressed and jump is less than 0, that's why we're going to use our AND operator. And jump is less than 3. Let's say 3. Now everything in Scratch is a double type variable, which means it's only accurate to 14 digits. So you can't go too crazy with this. So I'm jumping right now. I'm pressing the up arrow, but I can't jump more than 3 times. Actually, let's change it to 2, so it's a little more realistic. So boom, boom, and I can't jump again, no matter how many times I press up. That's how you implement double jump. Boom, boom. Alright, there's double jump. Alright. There's also a way to not reset it if you hit your head on a surface above you, so like a roof. I don't think that's like necessary. You can reset it if you want, but I guess I'll work with that later. Now, before we move on to collisions, there's one more thing we need to do, which is down. What does the down button do? Usually in most games, down like hard drops you, or like increases the gravity tenfold. That's a pretty easy fix. You can see that change y velocity is negative 0.5 right now. So we can change the gravity, or how much it moves by, if we press down, or we can change, where is it? This value, so that, if you're jumping really high, at a certain point right here, you'll just fall back down and you won't bounce again. Well, we'll change this value for now. I'm actually pointing at the screen right now, that's not really working. So, boom. So if y velocity, or if down arrow is pressed, where's that down arrow? Then we want to change the y velocity by, say, 1.5, negative 1.5. Alright, so this is without the down button, and this is with the down button. You can see that it's a lot faster. And it also has those small jumps, and that's why I said the other thing you can fix is this. So we can have a double if statement, or a nested if statement. So if down arrow is pressed, then we want this to be smaller, so let's say like 4 or bigger, so it doesn't bounce as much. There you go. Or we can actually increase 10 or something. So now just drop once it reaches above 10. That's kind of important for a double jump or gravity. Now we're gonna move on to actual jumping platforms. So say we want like something here to jump on. We can just add that here. Okay, after this, we're gonna actually move on to items, and then we're actually gonna move on to climate change. Cause I don't know if you guys are gonna use items or not, or you guys don't know what items do necessarily. So I'll help you with that, just in case you want to use it. Maybe you guys don't want to use it, but you don't see how good they can be. Alright, so here we have our platform. We can obviously, use this platform very well. But there's a small problem. We said here that if it's touching the ground, or black, it will go up until it's no longer touching the ground, so like that. But that just means we'll just go right through this. Now that's useful if you want this to be a one-way platform. That means you can't go down no matter what. But that's not useful in this case. You can also like do that. Alright, how do we make a, I guess, top hitbox then? Well, that's actually really simple. There's 2 ways to do this. Hitboxes are things that check your collision. So if your hitbox is touching something, that means it'll say, oh, you're touching this, you can't go there. We can use that as a separate sprite, or we can use that as the same sprite. If we set a separate sprite, we want it to follow wherever the circle is, but following it takes time, so it'll always lag behind a little bit, so we don't want to do that. We want it to actually be in the same sprite that runs the same code. So here we have our circle, but we're going to change it to a hitbox. So we'll change this to red, so it's very bright. Now we won't actually see this hitbox later on, Actually, I have to change this outline, don't I? Oh, I just changed you. There you go. That's a hitbox. How do we, let the hitbox do its thing and not interfere with whatever this thing is? Oh yeah, by the way, middle mouse button is if you want to drag the screen. You can also drag with the left mouse button, but I'm used to middle mouse button. Well, that's where cloning comes in. Cloning. So when I start as a clone, actually let's create one clone when we start. So our normal script goes to this regular guy, and our clone will have its own separate script here. This is an event, so this will run when this is run. Only once, unless there's a for loop. So when I start as a clone, I want us to always follow this. So I can use that goto command. Goto. Okay, I guess not. Scratch 3. Got rid of that. That is really weird. I can't. What? Okay. I am not used to that at all. Okay, well in that case, there's two ways to do this as well. You can add the same exact code here to the clone code. That means whenever the clone is exactly where this is, whenever you press left, the clone will also go left. When it goes right, the clone will also go right, and they'll be exactly stacked on top of each other. This means that they'll be in the exact same spot. This is highly accurate. Will also lag your computer a little bit more if your computer's not the best. The other way to do this is we'll set the x and y value of the circle to a variable, and then we'll read that variable here. So I guess I'll show you both ways. I won't show you the first way because that's kind of self-explanatory. So x pos, this is the x position, and y pos. Did I capitalize this? No, I didn't. X pos. Alright, now this is basic feasibility. You can change this if you want. Boop, boop. And then sliders if you want to change this. Which is kind of useful in some cases. But, alright. When I start as a clone, I want to get the position of the circle. That's kind of simple. So, there you go. Boom, boom. So every time this code is run, I'm going to get that x position. So set x position and y position, x pos, y pos, to the circle's x position or y position. Boom, boom. And when I start as a clone, I want to get that position. There's also another easier way to do this. You can just get it directly. So, well, there's a reason why I'm not doing that. When I start as a clone, I can just go to. I can just do this. This will work as well. But like I said, there's a reason why I'm not doing that. That's because I can change this. So if I want this hitbox to be 2 above the circle, then just do x plus equals, oh shoot, x plus plus 2, or x plus equals x plus minus 2, or y plus equals y plus 2, or something. So I can edit that really easily. Alright, here's our clone. Okay, I didn't add that forever loop. Forever. There you go. So now we can't see that clone. But it is there. It's always moving to the circle. So now that we know that, you can actually change the costume of it so it looks like this. Oh, not the regular guy. But we want our regular guy not to look like that. So we'll change our costume to 1. That's our normal one. We can actually change the name of this to normal. And this is the hitbox. Hitbox. Alright. So our circle is at normal, but we can change this to hitbox. So you can't actually see the red, but we know it's being run. It's in this forever loop. It's just behind it. We can see this if we put this in the front layer. So now we can see that it's there. It's working. It's fine. Now we can just go to the back layer now. Alright, so how does this help us? Well, if the clone is touching something black, then, we can do that. We don't have to actually run all the code on this guy. That'll just be catastrophic. Why is this not running? Wait a minute. What just happened here? Alright, let me just fix this real quick. Yeah, here. What is happening here? Looks like y velocity is not fixing itself with the absolute value of y velocity is less than 1. Alright, well, you can also fix this as well. Wait. There you go. No? Alright, this is why order is important. There you go. Now it's fixed. Alright, so we can move this back. Alright, so if our hitbox is touching something, we can obviously, I'm just gonna close this. We can obviously tell the yellow ball that it's touching something. There's two ways to do that. If we're jumping and we hit something, what is our y velocity when we hit that object? It's gonna be positive, right? So if it's positive, you can obviously say, if it's black and the y velocity is positive, then we don't go up, we go down instead. You can also say, like, you can also test if it's closer to the ceiling or the roof. So like, if I'm right here, and I touch this, I'm closer to the bottom than the top. So I can also say that. I'll go over that way, because usually that way is much more effective. So when I start to clone, I want this hitbox to move up and down and up and down and up and down until it finds which one is not touching the black first. Okay, how do we do that? So, we're gonna not do this if it's touching black. So, if not touching black, not touching black. So let's see if this works first. So I'm touching black right now. Actually, that's not gonna work because I'm not touching black because of this thing. If touching black, then we want to do that. But if it is touching black, so if I'm in this, like I can just do this, then I'll stop there because it's touching black. That tells me that I had made a collision there. So I can do that again, but going upwards. That's not working. Alright, that's not working because this is instant and it doesn't have a chance to do that, but we can fix that by making this not instant. So if it's touching black, then I can say, do you want to go down or up? So actually, is there a more effective way to do this? Well, first let's limit this to if the y velocity is positive. That's the first way I said you can do this. So if y velocity is positive, here. Nope. There. So if y velocity is positive, you can obviously do that by if y velocity is greater than 1, that's not greater than. That's not greater than. If y velocity. No. Not. There you go. Oh my goodness. There you go. If y velocity is greater than 1, or 0, my bad, that means it's positive. That means we're going to do this. We're going to change it by -1. You can obviously see that there's some problems already. When we're going down, then our y velocity is negative. But when we touch this thing again, then it's positive again. How do we get around this? How do we get around that? This is the ground, not like something like a platform. There's another way to do this. So, repeat until not touching color black. We want to change it by -1. But if this keeps -1, that's not going to work. So we're going to have to see how many times it is -1. So, check if ground. I know this is getting a little lengthy and a little long. But with practice, you should be able to do this. I don't know if you guys allow backpacks in your coding science Olympiad thing, which you can just use to copy code and just drag it on here. Well, whatever. So check if ground by 1. If this is actually, let's set this to 0. So when we start this, it keeps going down by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If it goes down by 100, then obviously it's not a platform. No platform's 100 big. Or if your platform is 100 big, then like 500. No platform is 500 tall. That means we know, that's the ground, and we're not going to do this. So we can use AND operator. So if not touching black, or repeat until not touching black, or check if ground is greater than a huge amount. So let's just say 50, because that's default. Oh, okay, I used the wrong operator there. My bad. There we go. So, oh my goodness, what is happening? If I lost it and repeat until not. Oh, I used the wrong operator again. This is supposed to be OR. I haven't played ping pong today. That's the reason why. Alright, now it should be fine. So you can see that it recognizes this as the ground. It might bug out a little bit, but we can also change that to not bug out. It's because this is going to the ground, and that's where it goes into. But yeah, now we need to actually add the collision that checks if this is in the ground. Get here. Oh, how do you do that? Okay, so actually let's make this a little thicker. Make this a little easier to work with. Oh hey, if I change this, that's pretty cool. The ball moves with it. All right. So this will give you a much bigger visualization on what's happening. So let's just go into the top. Get out of here. Alright, so we can check this thing the same way we did this. Let's clean up blocks. This basically cleans up your project. So where's the little thing? There you go. Just move it to the side. Alright, so check if ground, we're going to set that to do. We don't have to have a same variable or a different variable for everything, because this can only happen for this or this. So we're going to copy this too. And boom. Nope, I missed. No. Boom. Alright, that's just because it was on an infinite loop. My computer's pretty good, so infinite loops shouldn't be too bad. Actually, this not speed grader. Alright. Does this have to be greater too? Yeah, this one has to be greater. Alright, so okay, it's going out of existence because it's checking this, and this is that actually running instantaneous. I don't think backpacks are allowed. Backpacks aren't allowed? What a scam. Alright. So, our little hitbox isn't really working out. So, this is 50 up. We can check that because, we checked this by going 50 up. That's where our hitbox landed. So, that's good. The rubric doesn't say anything about them, but it's completely supposed to be reset for the next competitors. Alright, well, I guess that makes sense. Alright, I just lost my train of thought. Just kidding, Primary never does that. Alright, so if this happens and check if ground is greater than 50, that means this platform is definitely not going to work. Actually, this should probably be 10. So, we stop this loop statement because it's not going to work. Then we have to put it back to its original spot. How do we do that? Well, that's actually pretty simple. We can just do this if check if ground is greater than 10, because it might be that it's not touching black. That would work too, but we want to make sure it's this case only. Then we want to change the Y position back to what it was. So change Y by a negative change, because check if ground is how much we change by. Okay, that's not working out. Let's see here. I put it on the wrong place. $50 and 10. I should probably change it to 10. Alright, that's not working. Oh, I have to debug this again. Alright, be until not touching black or check if ground. Wait, in your case, you wouldn't have to debug this because you can just practice this beforehand and memorize how it looks like. And it's just a matter of repetition. I actually never did this before. Alright, so repeat until not touching black or check ground is greater than 10. Change over -1. Okay, that's if I'm up here. So this part's working fine. Yeah, it's working fine. Alright, if you want the glitchy thing not to happen, we can just run an instantaneous command to do this, and that won't happen. I'll do that last though, because that's not really necessary for me right now. And alright, let's go back here. We want this, if we jump up here, to go back down. How much did it jump up by? Well, that's check if ground. And if it jumped up by 50, so around here, that means we have to move it back down by 50. Our hitbox is doing a very good job. Alright, so look, our roof is working. So you can see that we can no longer go through this. Now there's that little glitchy thing, but we can just fix that using the instantaneous command I talked about. So just instant oh shoot, there's an extra T. Instant get out of ground. And we don't actually need any inputs for this, cause why do we need inputs? Yeah, I checked this on instant, didn't I? Alright. So we can do this, boop, and a boop. Did I run this on the wrong thing? Wait, no, I just gotta save this and stop this. I just gotta put this if statement here, because that's also taking time. If y velocity, I can just do this here, or I can just do if not, but it doesn't really matter. I guess this instance not working. This is not a problem with this code. I know that for sure. Because the code is working fine. It's just not doing it instantly. That's kind of... Wait, that one... This one's instant. But what? This one's not instant. Yeah, this is not instant. It's actually checking it. How would I make this instant if the instant's not working? What? Oh, yeah, okay. I'm gonna ignore that for now. I'll probably think about it a different way. But we also have to make sure our double jump doesn't reset if we touch the ceiling, assuming that you don't want that to reset. We can just do this. If y velocity is greater than 0, then we just don't do it. Check the double jump. Alright, where's our double jump code? Alright, if touching color is 0, then we set from 0. We don't want that. If touching color is 0 and y velocity is positive, so if, I'm just going to copy this, y velocity is greater than 0. Oh, alright. Go up, hurry up. Wait, what's that? Well, I just skipped it. Alright, so let's go down here. Okay, that's resetting it. Alright, whatever. I am really tired right now. I have no idea why I'm so tired. Alright. It's okay. If I don't fix these problems, I'll just hang out to you. Alright, so I have no idea how to fix this instantaneous problem. If this is instant. This is instant, right? It is instant. It's not doing it instantly. That is really weird. What? Alright, anyways, I'm just gonna move on. If by any chance you forget how to do this, let's open Scratch on a different window. Cause I basically explained how the platformer works and how to make it and understand it. You can also look up, that's my sister, so don't worry about that. You can look up any of my previous platformers, such as, remember this thing? This is where I made that other tutorial. So this is using the same platformer system. So you can see that this platformer is also working. This roof system is also working. It's actually working flawlessly. What in the world? Oh yeah. So you can use this instead of my code. I already told you how to do that. So you can just use this. You will understand it now that I taught you. So if you have more questions, you can ask me on Hangouts. So now let's get the items working. Okay. I would just copy the code, but I'm too lazy to do that. How do we make items? What do items do? So this is why we have to use variables for gravity and stuff like that. Or y position, x position. For your climate change thing, I don't know what else. I don't know what you guys were thinking about the project, but if actually I don't want to open that because I don't want, just in case any of that's private. But your theme was climate change. Now the first thing I had in mind was a 2.5 dimensional game, but 2-dimensional game is preferred. So I was thinking, this is a guy, so you can just animate or costume that to be a guy, and say you wanted like a storyline. So you can have like a storyline in the beginning, so you can have a lot of costumes and text that says like an event that caused a huge climate change. And then I was thinking this guy can like go around places, explore new areas, and getting different people to help him stop the climate change. I don't know. I mean, I don't even know how you make a climate change game. Yeah, but that's basically what I was thinking. So you can do that, I guess. But if you're gonna do that, we need items or people. How do we make people? So let's make a new sprite. Let's just make a new sprite, like costume wise. So let's make a person. Super Gamex. I do not understand that. I'm sorry. Boom, 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 boom. That guy's a little big, but it's okay. Okay, so there's a guy. Say that's like, I mean, if you guys have an idea on how to make this climate change, I'll just do it right now. tell me in the live chat and I'll make it. But say when this guy or when this character touches this guy, then and say there's like 4 guys around scattered, then they can just help you fight the climate change. We can have like a background. So actually, I'll help you with that. Actually, um, pretend these are meteors. Don't worry about how legit it is. It's just meteors. Um, okay, meteors are a little extreme for climate change. But whatever, games have to be drastic, you know? Alright, so forever. Wait 1 second, and create a clone. Alright, so every 1 second this will create a clone. When it starts clone, go to a random position. Pick a random. I need 2 of you. And I just want to go to a random position. Actually, I'll just make it go to y equals 200. Oh, oops. 200 and x is random. So negative 240 to 240. That's the dimension. Oh, excuse me. Y doesn't go up to 200, but we don't want the meteors to start out in the screen. Oh, I am. And then we would just want this to go down. So glide to another random position. Except y is at negative 200. And then after it's done doing that, then it deletes this clone. So what I had in mind was these people will help you stop when the people touch the meteors and the climate improves. Oh well, I was thinking something not of that line, but I'll tell you what I was thinking, and then I'll try what you're thinking, cause I'm almost done with what I was thinking. So go to the back layer. We always want the clones to be in the back. This is like a background, which is what I was thinking as well. These meteors are in the back, and let's hide the main meteor and just show the clones of it, because the main meteor is not actually moving. And we also want this to be smaller, so change their set size to 50%. And set size to 50%. There you go. Actually, let's do it. 50% should be fine. And then let's also change the costume. Our backdrop is actually in front of the meteors. I'm gonna assume you guys know how to do this, because it's just gonna waste a few seconds if you get. So pretend these are actually good looking meteors, and pretend that the backdrop's in front. So here we have our background. It's raining meteors and stuff. This little guy, this guy, can go help find people. We remember in our old Scratch project, the Science Olympiad 1, my stuff, Science Olympiad. We had a scrolling screen. So that means that if I go here, then this screen scrolls. Now, if you guys know how to do that, then you can do that. But if you don't, we can just go back to that old tutorial. So we can go through different screens, and we can just find these people scattered around Narnia, and we can just ask them for help. And then they could be like a dialogue scene. So this person, if so, forever if, let's add an event, forever if, and then touching. There's a touching right here. Touching the circle. If it touches the circle, then we want it to talk. Oh shoot, I just knocked my water bottle over. We want it to talk, so you can say hello for 2 seconds, and say something like, how may I help you? I am really bad. How may I help you? There you go. And then the circle can respawn. There's a thing called asking. So if I say ask, or I can just ask that. ask, how may I help you? Then, if I touch this, it says, hello, how may I help you? Then I can insert something like, give me muffins. Well, realistically, you should say, do you know anything about climate change? Something like that. So, how do we sense that? If, say, the answer is, now this is a numerical value, but we can also use this as a string value. So, the answer that you put in is obviously going to be text, and text is called a string value. So, if the answer is like, can you help me with the climate? I don't know. I'm not a climate change guy, so I don't know what to say. Can you help me with the climate? So if the answer is him, or if the answer is that, then he can just say, sure, and then, I can't type. And then, you can also change for how long he says that. And he just talks about the climate change. Climate change is blah blah blah, and can be fixed, can be how does, I don't want to be like fixed, but like can be yeah, slightly fixed, I guess. That's a weird thing to say. But climate change can be fixed and blah blah blah. You might want to go ask a different person about it, like a meteorologist or something, I don't know. And or like go to a certain place. Then the little guy can go explore more places and he can go ask them. Eventually they'll have an answer, and yeah. But one thing. If I go to this guy, climate change can be fixed by blah blah blah. Go ask Mr. Mr. Muffin about it for help. Helped in a positive way? What do you mean helped in a positive way? So like, hello, how may I help you? I can just put, can you help? Can you help me with the climate? It has to be the exact same words, but we can also do like answers this or answers this or answer this. Sure, climate change can be fixed by blah. Go ask Mr. Muffin about it. But this guy's gonna say the same thing if you interrupt him again. And our clone's also interrupting that. Obviously, we can just hide the clone. I just didn't hide the clone. I can just put hide right there. Oh, not there. Where's the clone costume? Boop. Alright. And then I can, reduce this so that it doesn't run again. So, say if I already ran this, I can just have a boolean variable. So, is it already run? And if it's already run, so set a variable doesn't have to be a number. It's already run to false. Boom. And then, if it touches the sky and the answer is this, then we change that to true. And then we can also make it so that it'll only ask this if it is true or false. So equals, it's already run, and false. I realize this is uppercase, that's lowercase. So yeah, that's how you prevent this guy from asking twice. Well, if you don't answer, then you can obviously ask him again. Then you can put, can you help me with climate? With the climate. And then now if I go into him, he just says hello. He doesn't say anything else. That's good. And then we can use the scrolling thing. And say there's a different guy or something. I'm gonna hide this. And hide this and this. and this, and this, and this, and this, and this. Alright, let's look at this go party. It's okay. So, now that's out of the way, we can just go to different people, and eventually, there'll be that last guy who explains the entire situation, what's happening. And, you know, he'll help you with everything there. I mean, that's up to you to decide how it ends. But now, I think I got the basic idea out of the way. Now, if you have any questions, comments, concerns, or anything that you want me to try, or anything you want me to help you with, you can do that, or ask that. Please no more than 1.5 hours though, because I don't want to sit in front of my computer for 1.5 hours. Yeah, here, I'll leave this project open. Here, Scratch, Science Olympiad. Here, I'll share this too, so you guys can see this if you want. I did share this. I have no idea what you're talking about. So if you have any questions on how code works or how I can do something, you can ask me. I'll go back to the previous project if you need it, but yeah, I'll just wait here for the next 30 minutes if you have any questions. Or if you want me to go explain someone's project, or if you want me to explain some of my old projects. Actually, most of these aren't even mine. Actually, most of them are mine, but, you know, my sister has a lot of them too. Hey, there's Battle Cats. Yeah, you can also do, like, if you want your game to be from, like, a bird's eye view instead of, like, a front view, you can also have a game like this, where this is like the top view, and you can just move this character with your arrow keys. Now, obviously, what happened here? Oh, all these gray walls are too small. Alright, whatever. Scratch 3.0 ruined a lot of my projects, but whatever. If you guys have any questions, just ask me. I'll just go through some of my old projects showing you some of the code, and I'll just explain it if you guys don't have any questions. This is gravity physics. This is also from like a top view. If you want a person with the top view, you can obviously do like if left arrow, just do the y velocity and x velocity. And you don't need gravity because you can't see how high they're jumping unless you use the size of it, so it gets bigger as it's close to you. But I don't think you'll be too worried about that. So yeah, you can do a lot of stuff with bird's eye view. It's a lot more creative and flexible. So like here, I just added gravity. This isn't very hard to do. This is all the code that you need. See, it's pretty simple. So, yeah. I'm gonna assume you have no questions. Do you guys have questions? Is this you? What does this say? Hello, hello. Uh, okay. Do you guys have any questions? Would you suggest memorizing all the coding you did in a specific tutorial to try doing it faster in competitions? No. If you want to make a game like this, I'd recommend logic and getting to know the code better, knowing the environment, knowing the shortcuts. So Scratch is a really bad example for shortcuts because there's so many shortcuts you can do. So I'll show you in a more advanced program. So, like say in Scratch, let me open Scratch again. Say I don't know what to say. Say like optimization. Then oh hello, Sean, Sheen, Scene. Alright, don't worry about this right now. So, optimization. If you want your character to do some action, you want to do it in the fastest way possible. You also want it to do an effective way possible, as in like your computer doesn't lag. And you also want to do it in the least amount of code possible. So with the gravity, let me go to my stuff. We could. I'm really lagging. Alright. I don't know if you guys understand Java, but there's a thing called hard coding. Hard coding means basically there's different situations you can have. So like for Tetris, you can have 7 different pieces, which we have 7 different pieces right here. And every time we want to rotate it, we can't, or we could like say for get every single possible Tetris piece and every single possible position on the board, and then like see what position it's in and what rotation it's in, and then change it according to its position and rotation and piece. That's not very effective. You're gonna have to do like the entire Tetris board, which is 200, and every piece possible and every rotation possible. Instead, you want some code, which I represented here, to here. It's a lot more effective. You're not getting every single possible place on the board and every single piece. Instead, you're calculating all the possible places and putting them accordingly. So I'll try to show you a Scratch example. It's just usually you want to see this in Scratch. Oh yeah, so like gravity physics. I don't know if you guys will use this, but so I have to. These are not thick enough. Wait, are they hidden? No, they aren't hidden. Why are these not showing up? Excuse me, what? Is it their fill? No. What in the world? Scratch is weird. No, I don't want. Why are you guys not showing up? Show. Okay, well, basically this is supposed to be like a gravity physics. But we don't want to calculate this ball and every single slope possible. Like, if there's a line right here, which you can't see, we don't want to get like every single possible distance that this ball is dropped from and calculate every single possible direction this ball can move, every single drop height, every single velocity. Instead, we want to get that velocity and use calculations to see where it ends up as. That's called soft coding. So you should probably really get used to soft coding, so that like here, we don't want to see every single velocity, we want to calculate with that velocity. Probably practice that. The other thing you should practice, this is a huge thing, is logic. So when you make a project, you're probably going to make a lot of mistakes. Like here, I made 2 or 3, oh shoot, I almost fell off my chair, really major mistakes in this. I definitely could have fixed them, but I also definitely could have made a lot more mistakes. It's just that I'm used to Scratch. I'm not used to Scratch, but I'm more used to Scratch than some people. So that's why I didn't make as many mistakes. I'm comfortable with the environment. So you should probably just make a lot of basic projects at first, and then make a lot of projects relating to what your game is. So like I made a few games like this before, so I knew what I had to do. It's just a matter of remembering how and the logic. I didn't make the exact same things, so I gotta use my logic to, change up some of these values, change up how these are run. And obviously, if, like, I never did this before, obviously, it's kind of weird. But, if you practice your logic, then this should be really easy to know how to do in your mind without even seeing it. Like, I could say, oh, I know how to do this. If I see this, I can do it. And I can do it. So you should probably practice looking at other projects too, trying to understand how they run. So if I look up, what's a common project? Mazes. That's not mazes. Wait, no, that's ignore that. This was a search bar. I really need to play ping pong. If I look at mazes, all right. Yeah, like this one's unique. Let's try this. So we can see that this project works like this. This is a backdrop. What just happened? So basically, you want to go look at different projects and see how they function. So here, I'll look at this Pikachu right here, and I'll see, wow, this is a lot of code. This is not very effective. And I can see that this is the actual raise money part. This is just colors. This is basically broadcasting messages. They're not really useful. But I can also see that if I absolutely need this is all really similar. All I have to do is change this. This is the only thing that changes. And also the color. So it's going to be really easy to just copy paste this, duplicate, and then put it over here. So it's going to be really easy to do if I absolutely need it. Now let's get this. If up arrow pressed, change Y by 2, and we change the costume. So I can see how that works. Now you should look at a lot of projects to see how they work and see which one's the most effective code-wise. Like this one, I can see that if I run this way or here, it's gonna be glitching out, going all around. I can't move in this corner, like outwards. I'm pressing left and up right now, so you can see that's not working. So maybe I can edit this, which is a good thing to do. If you don't see a project that's working, try to edit it and make it work. And you should also look at different projects to see how they tackle the problem. And yeah, basically you just want to see other projects. What in the world? You sort of see other projects, see how they work, and see how yours work. Don't touch the flag. So, well, okay, without looking at the code, how do you think this one works? Can you show how to fix it? Should I show how you fix it? I don't know if you said, oh, never mind because I went out, or because you figured it out. Alright, this one works by, the movement, and if touch color black, we want this to move back here. And if this is touched, then we want to change this to look like a different maze. So, I guess I'll show you how to fix it. Unless you don't want me to. I guess I'll show you, alright. So, Pikachu. Let's start this project. How does this code work? So, when up arrow is pressed, we change this. But when this is no, it's fine. You can figure it. Okay. So when this is touched, it goes back, but it waits a little bit because it waits a little bit before it goes back. Why is that happening? Well, that's because there's a delay right here. When up arrow is pressed, it moves, but it also has to wait 0.01 seconds before it can check if it's in a wall again. Let me just move this here. We can see that it's no longer glitching into the wall. And just do that same thing right here. Just move this. Boom, boom, boom. Or if I absolutely wanted to and not make any bugs or at all, if you forget that you can't have any delays, you can just ignore this bug as a whole. Do this. If key down pressed and or I can just actually use the if statement. If key down pressed and touching color black, then we don't want this to run, except when it's not, it runs. Or if key down pressed and not, where's the not? Not's down here. And not touching black, then we want this to run. This is another way to say this, except you don't have to remember that you can't put delays. But now that we did that, this should be fixed. It's not. Okay. It's looking a little glitchy. That's because the Pikachu is actually jumping. Why is this moving? The costume's actually going up and down. That's why it's moving there. But it's not actually, going into the wall now. Just want to practice now. Why did you guys view this already? Wow, that was really fast. Alright, sheesh. Okay. I guess do you guys want me to share any of my other projects? Like, I'll share this one if you want. If you guys want to see how it works. Yeah, here, share it. Do you guys have any other things that you want me to make? Because I have an hour right now. I mean, I can obviously go longer than that, but if you guys say you want me to make a tank game, I'll show you how to make a tank game, and I'll make one in front of your eyes. I don't really mind. This is a tank game that I made a long time ago. Boom. I can also change, like, these are the upgrades. Click on the upgrades. Insufficient funds, insufficient funds, and there's different ways of enemies. And then there's also different types of enemies. There's also like hearts and stuff. There's also like bombs. I completely missed that. I feel really bad right now. Different enemies give you different amounts of money. I'll show you how to do this if you want. My username is RCBCASC. It's on the top right. So bombs also have a cooldown. So there's your cooldown. I think my sister added that. Anyways. Oh, actually, I think someone else added that. So there's our bomb again. Oh my gosh, I really need to get rid of that. And then if I die, obviously, I died, final score. So, I'll teach you how to do this if you want. This one is tiny bit more complicated though. It's only a super tiny bit more complicated. So, I don't know if you guys... Oh, see, it's already lagging so much. All these are lagging because how many waves there are. Respawn @respawn is username on Scratch is oh yeah. Thanks for helping out, Super Gamer. So I think you guys all know that I can make a lot of Scratch projects. So any other projects you guys want me to make? Or this is called hard coding, by the way, right here. You can see this is hard coded. I can fix this. So instead of saying define animation like this, I'll actually show you on a different project. I was not very effective with this. So I could say the same thing there. What I did was I did wait 0.0. I'll just do 0.1 because that's easier to type. 0.1. Then change x by 1. Change x by 2. 3, 4. What's another way to write this that's much more efficient and you can apply this to any type? So like here, this rotation system applies to any type of rotation. I mean, there's little bugs in it that I have to fix, but for the most part, it applies to any type of rotation. Whereas hard coding, if I actually find the value of everything and, do all that, that's going to take forever. And every time I have to add a new piece or add a new whatever, I have to add all the possibilities of that too. I'm going to close this now. Well, if you soft code it like this, how do you soft code it? I could make this go infinitely, but then I have to, duplicate this and go infinitely. Well, actually, I can just do this. I add a variable. This is how much you change x by. Change x. And then I can go to control. Repeat 4 times. Don't repeat. And then change by x. I can just change x by 1. So these two do the exact same thing. Well, actually, let me set x to 1 first. So here, boom, boom. Now this is a little less noticeable, so let's change this to 5, 6, 7, 8. That should be a lot more noticeable. Let's see what this does. Ready? You can see that does that. Actually, let's do it back here. And what does this do? They do the exact same thing, except this one's a lot more efficient. So you also want to learn how to make this more efficient. So efficiency, logic, trying to figure out how things work without actually doing it. And yeah, that's basically all you need to practice if you want to get good at Scratch. You also want to learn what all the blocks do. So say I didn't know there was a rotate block, then I would actually have to use the distance formula and calculate, or if instead of just like rotate left, move 5, I have to like make a right triangle, get 5 divided by root 2, and move the character in the x position by 5 times root 2 and y position by 5 by root 2. So that's why you gotta actually know what all these blocks do. Also over here, you can add blocks here. So if I want to add a translation, like area, boom, I can use this. This is a numerical type variable. Remember we established that here. So I can translate. This is also a variable type, so I can say, or string type, so translate muffin into whatever, Chinese simplified. Translate it. Boom. So I can say that. So you want to learn what all these blocks do just in case. Also, you can see that this requires Wi-Fi, this requires Bluetooth. So you also want to make sure that you have what you need. These can be really important if you want to learn how to use songs or sound effects in your game. So like if you like in Minecraft, when you jump, there's a jump sound. When you die, there's a death sound. You might also want to do that. So when you jump, you can just say, when I jump, play snare drum. Oh. So yeah, except, that's a really bad example. Pen is also an extremely useful tool to use. Pen basically, okay, so pretend that there's a pen right here. And if I do pen down, that means I'm putting the pencil down, or pen down. And you can see that I created a mark. This is where the pen was. I put the pen down there, and I moved the pen this way. The cat actually moved that much, so the pen stroked that much. I can also like stamp. Oh, I keep forgetting. So you can see that stamp also works as well. Here, let's just do this. So you can create some really cool effects with stuff like this. Stamp just stamps it. If you want to clear everything, let's just actually do that. You can just press erase all. Change the pen color, change the pen attributes, set the pen attributes, size of pen. Yeah, so. And pen up is obviously lift the pen up. So if you guys don't have any more questions or any more things that I have to say, or I should say, I'm gonna go stop the stream. I need to play ping pong. Alright. So no questions, no comments, and if it's like, alright, thanks for liking by the way. If it's 3D games, I don't think I can do that right now. I'll wait 6 minutes until 2:10 p.m. for any questions. I don't think you guys have any questions. Do you guys have any questions? No? Yes? Maybe? Do you guys have any questions? Here, I'll put on some interesting music. Nine. No. If this video ends before anyone says a question. Alright, scratch thing. Alright. Or tank thing. What do you mean by show us the tank scratch thing? Do you mean like how it works? Or how to play it? Basically what I did, I used the WASD or arrow keys, they both work. I also have a velocity. You can see that this slows down. And this little character will face whatever direction that your mouse is. If I go here, it'll shoot that way. And I go here, shoot that way. And then you click this for upgrades. Like this is how fast your bullet moves. This is how many bullets you shoot at once, and these are just different upgrades. Like you get more money, your bullet moves faster, your bullet's stronger, you have more lives, so on. That upgrade actually doesn't do anything. It's just because I don't know what to do with that. And then here, bomb is for, or space is for a bomb. And then obviously when you beat all the enemies, you progress. Your money is right there. Each enemy has a different amount of HP and health, which I can show you. I used a list. These are all the variables that I used. It's a lot. So these are the current enemies. This is the enemy list. So if I go over here, I guess I'll show you how it works. I'll show you the costumes first. So these are different enemies. I corresponded each enemy with a certain health value, obviously, because each enemy has a different amount of health. So if I have enemy number 1 right here, then enemy number 1 has 1 HP. Enemy number 2 has 3 HP. Enemy 3 has 10, and so on until enemy 7 has 500. Now, each enemy also has a different amount of coins that they give you when you kill them. So, like, for example, each enemy also has a different amount of speed. This is how fast they move. And those are strong enemies. Oh, actually, I just put that here. These are just waves, don't worry about it. And I just added the speed and stuff. Oh boy, I don't know where that went. Where did that go? My computer is really laggy right now. Wait until not bomb question bomb equals 10. Oh, okay, that didn't go there. You went there, didn't you? I'm gonna get rid of this Al Akbar. I guess I'll tell you how it works now. So this is my character, right? Broadcasting is another way to call functions, except it calls functions outside of this sprite, or it's like an event. So here we have our velocity. We already mentioned how we did velocity, right? Velocity. And obviously this is the boundaries. So like if my character is here, I just prevent it going past it. So if it's, at this top, I just put it back to where it should have been. So now, you can't move past it. Attack, so like this is a function event that calls. So when I attacked, my HP reduces by 1, and I change my costume to a shielded costume, which I am invincible for a tiny amount of time. And obviously when I open my shop, which is this, I hide my character and my def and the velocity. projectiles. This gets a little complicated. So, hide the projectile, always go to the player. You always want the projectile to go to the player, because if I shoot the projectile, I want it to start at where the player is. And here's the speed of the projectile, how fast it moves. So if I see that, it moves pretty fast. Change this to 1. Then that is a ridiculously slow projectile. And this is how fast I fire. I can just press hold the mouse. Oh, what did I do? Wait, can I undo? Oh, yes, I can. So firing speed. If I change, or this is the lower the better, then I can just shoot really fast. Right? So how I did that is basically if your mouse is down, then or mouse down basically means if you click the mouse, then you shoot. And then you wait however many seconds your firing speed is before you can shoot again. So that's kind of self-explanatory how it works. And the shot, switch cost to shot, because we don't want it to be a bomb, we want it to be the shot. And then here, create a clone of myself. Why do we create a clone of myself? Because every projectile or every costume can only have one of itself. And if I'm shooting a lot at once, then I can't hold all of those, so I have to use clones. And then when I create a clone of myself, if shop is true, hide, where's clone? Where's this clone thing? When I start as clone. Oh, yeah, I just skipped right over it. So when I start as clone, I want it to show. I don't want to show the original projectile, because then this is just going to be a random projectile right there. And it's also going to lag a little bit more. Just a tiny bit more. But basically neglectable. If costume number is 1, we set it to 1 because it's, fire and the bomb's over here. If costume number is 1, which is the shot, then it will act like a shot. Change projectile clone ID by 1. We want to give a different ID to each projectile. So if I have Drew on the board, I want to distinguish each projectile from each other one. So this one's ID 1, ID 2, ID 3. That's how I can distinguish them. And then obviously, if I have them set to a variable, then this is 1. And then if I change it, the projectile variable to 2, then both these will be 2. And if I change it to 3, then all 3 will be 3. So I have to actually use a function that calculates whatever it needs to, depending on that. And then this is basically how you do multi-shots. This is basically just how you draw it. So I guess I'll show you how to do that. Where's fire mount? Shot fire mount. Right there. So if I shoot one at a time, then it'll shoot one at a time, and I don't really need an ID because there's only one on the screen. But if I shoot 5 at a time, I need to know which one of these 5 will go in which direction. So I have to have an ID for each one of these. That's why I set the ID over here. So I know, like, this one has to move right there, this one has to move right there. And then, yeah, shop upgrades, I think that's kind of self-explanatory. When you click on this, this will move, and it'll ask you a question. Remember we did the questions? So, touching mouse pointer and mouse down. So, if you're touching it and you click on it, and you have enough money, then it asks you, do you want to purchase the item? Then you say yes. You subtract that cost of whatever upgrade that was from your entire money, say it was successful, and close the shop. And then depending on what upgrade that was, here, if ID is 1, it was that one, ID is 2, it was that one, whatever, it'll give you a different upgrade. And then this is basically just how much each one costs. Because, I have the costume set like this, but it can't actually read the costume, so I have to actually set the value of how much it costs there. And then, yeah, if it touches it, then it just moves. What did I do? Alright, I hope I didn't mess up anything, but if I just touch it, then it runs this and it moves. That should be pretty self-explanatory. So I explained the projectiles. Health. Health isn't too hard to implement. Basically, just have 3 hearts right there. We want one to be here, and then if there's one already there, which you can check by how many hearts we have. So if we have 1 heart, then we know to put it there. If we have 2 hearts, we know to put the second one there. And if we have 3 hearts, we can just put the third one there. We can check that by how much we want to change the heart position by, and how many hearts we have. I think you guys already know how to do that. Oh, what did I do? There you go. Shop button. How do you implement a shop button? Well, you just put a shop button wherever it needs to be. And then if it's touching your mouse pointer, so if I click here, that's not going to work. It has to touch it, and I have to click down on it. Then it moves to the shop. And then obviously, if I click on this and press hold it, I can't just keep switching back and forth. I have to wait until I'm no longer pressing it. And yeah. Alright, these are the upgrades. Bombs. Bombs are a little tricky in how they work. So you want your bomb to like stay there and explode. And if it touches anything, then, you know, it has to kill it. And how are you supposed to know if it kills it? Well, basically, if your bomb touches any enemy, then it kills your enemy. Your bomb also has a countdown. So every 1 second, every 1 second, it, reduces the countdown. And yeah, that's how that works. And when I press space, I gotta make sure the bomb timer is at 0. Otherwise, I can't use the bomb. So if the bomb timer is at 0, and I press space, it resets the bomb timer to 10, and I can use the bomb again. When I use the bomb again, I gotta make sure that it stays in this bomb costume, this black bomb costume, and then when it explodes, I have to actually make the explosion. Well, that's pretty simple. Just set the costume to bomb, wait 1 second, and then quickly change the costume over and over again, so it looks like it's an explosion. This is just the shop right here. Basically, when you pass this one around, it shows up. So like if your wave in this case is greater than 25, then it says new upgrades unlocked, and it's just a pop-up message. And the strong enemies, this is basically the same as the regular enemies. Now these enemies are nowhere near easy to code, but it is most definitely possible, as you can see, that I have done. I'm not going to tell you how you code these things, because these things are monstrosities to code. Basically, we do the same thing with the shop, or projectile. We set an ID to each one of the enemies on screen. And when all the enemies on the screen is gone, and the wave has ended. So if I kill all the enemies before the wave has ended, that's not going to work. So I have to have a variable that says round end. So then I'll change that to true if the round ended. So if the round end is true and there's no enemies, which I have a list for, so each enemy has an ID. Remember I told you that? HP list, so wait no. This is how much HP each enemy has. So like enemy 1, their ID, has 0 HP. That means they're dead, and I get rid of that. So if I see that any of them are 0, just remove that one from the list. Delete whatever of that list. And then, when all these are gone and round is done, then we start the next round. They follow you really simply. They just face in whatever direction you're facing and move 10 steps. It's pretty simple. They just follow where you are. And it doesn't have to be 10 steps. It's however fast the enemy is. That's how you did this. It moves 2 steps, 2 steps, 1 step, 4 steps, 2 steps. And then, yeah, basically, you just do that. The HP of the enemy, it's a little hard to work with, but basically, if a projectile touches it, That just means reduce your HP by however strong the projectile was. We can get how strong that projectile was by either like how strong a projectile is. So projectile, there should be a projectile strength somewhere. And then also you can, if you don't want to do that, you can just get the ID of the projectile and find it that way. But mostly I can't just explain this to you. That's gonna be really hard. It's mostly seeing how it works for yourself. If I get rid of this, what will happen? If I do this, what will happen? What will run? And if I look at this, how does this work? If wave is 2, wait a little bit, and then make sure that there's no enemies and no clones on the screen. That means no clones of enemies. And the round is ended. That means round 1 is ended, and it's wave 2 now. Then we start the round, and we create the clones of myself. That's the actual enemies that's coming. And then we set, or these are all the normal enemies, and then we set the costume to strong, and then we create another clone. So this clone has a strong costume. And depending on what costume it has different attributes. Well, how do we check that? Well, there's a costume here. So if the costume number is 1, then it's a regular enemy. If the costume number is 2, then it's a strong enemy, and so on. And obviously we set the round end to true. And that just happens for every single round. Eventually that's going to get really laggy though. So you might want to put the rounds on a different sprite so it shares all the code. So you don't want to dump all the code in one area. So yeah, that's basically how this game works. I know it's a little complicated, but it's fine. And there's a 0% chance you're going to code that in 50 minutes. That's not going to happen. The rounds itself took like 3 hours. Okay, 2 hours are YouTube, but 1 hour is actually coding. So any other questions? Alright. I don't know if you guys are looking at this right now. I don't remember what view count it was at, so I don't know if you saw it. If you guys don't have any questions, so I'm just gonna leave. Okay, I have to clean my room. I will be back in around 10 to 15 minutes. Well, I don't know. Do you guys want me to say more things? Or if you guys want me to make a project, then I'll make it as a separate video and upload it later. But I don't. If you guys don't need me as a live stream, then Alright, I'm gonna assume you guys don't have any other questions then. Alright, well, I hope you guys enjoyed this live stream so far. And yeah, until next time, don't forget to turn off your sticky keys. And let me just close this now.